Hey everybody, in today's lesson we're looking at Cambridge Exercise 3L from the Year 8 textbook, and we're studying how to use Pythagoras theorem in further problems. So let's start off with question 8. Here is a diagram showing the path of a bushwalker from camp 1 to camp 2. So over here to over here. Find the total distance, calculate to one decimal place. Well, we've got this distance here, which is 3 kilometers, but we don't have this one here. So we've got to find this, which is directly opposite the right angle there. That means it's a hypotenuse of the right angle triangle. So remember our formula is c squared equals to a squared plus b squared, meaning that c, which is this distance we're finding, is equal to 2 squared, okay, which is this distance, plus 1.5 squared. So we then put this in our calculators, and that will generate 6.25 in total. And if we square root our answer, okay, then c would equal to the square root of 6.25. Okay, then once I put that on my calculator, I get an answer of 2.5 kilometers. So then the distance in total will be the sum of the first distance, which is 3 kilometers, that's this distance, plus c, which we know as 2.5. So 3 plus 2.5 would equal to 5.5 kilometers. Let's go to the next question. Question 9. A 20 centimeter straw sits in a cylindrical glass as shown. What length of straw sticks above the top of the glass? Sticks above the top of the glass. Round the answer to two decimal places. So here's a straw. And we know that this part of it is going to be a right angled triangle, as we can see, but there's a bit of the straw that is sticking on top of it, but the whole straw itself is 20 centimeters. So let's just put that there, so you can see that. So that's 20 centimeters for now. But in this triangle, if I was just to find out what the length of this is, okay, all right. So it's just part of the straw that's the hypotenuse of this right angle triangle. We can see that if I call this c, then c squared equals to 4 squared plus 14 squared. Okay, so just by using that as a shorter side and that as a shorter side, but hold on, I've done a mistake. Because if we look carefully, that 4 there is a radius of the circle on the bottom. So this part is actually 8. So that's actually 8. And this is 14. Right? So if I then redraw that triangle out, this is 8 and 14. So I'm trying to find c, which is this. Okay? So c squared would equal to 14 squared plus 8 squared. And that will give me 260. And when we take the square root of 260, it doesn't give us a very nice number. It gives us something like 16.1245, etc. So we're not going to write that down. We're going to write c is equal to the square root of 260 first. This gives us the exact value. Okay, and we like this more because it's not rounded. And so our last answer that we're going to generate is the part that's sticking out above the glass, and we'll just call this x. Okay, so x would equal to the total length of 20 of the straw, subtracted by the part of the straw that is inside of the cylindrical glass, which is the square root of 260. So if we then get these two subtracted by each other, x would equal to 3.875. It keeps going, but if I round this number to two decimal places like it says there, then that 5, which is 5 over 5 obviously, would round the 7 before that to an 8. Okay, so it's 3.88 centimeters. That's sticking above the glass. Okay, next we've got question 11. Prove that these are not right angle triangles. So to prove that these are not right angle triangles, you've got to prove that this statement, which is our Pythagoras theorem statement or formula, is not equal to each other. So let's identify where C is. C supposedly is the longest side. So let's write 7 squared first. That's the same thing as c squared. Okay. So 7 squared is equal to 49, right? Then let's find out what a squared plus b squared is. Okay. So that will be the other two shorter sides squared and added together. That's 5 squared plus 3 squared. Once I add 5 squared plus 3 squared, I get 34. So because 49 is not equal to 34, that means c squared is not equal to a squared plus b squared. Okay? And therefore they're not right angles. So we can write that. So we can say, therefore, 49 is not equal to 34. Okay? Therefore, the triangle is not right angled. I mean, to prove that it's right angled, these two numbers have to be the same. So if this is not the same, they're not right angled. Question 12. Find the perimeter of these shapes correct to two decimal places. So remember, the perimeter is the distance around the outside of a shape. So in this case, don't be confused by this 4 here. The 4 is what we call the perpendicular height. That is not the slant height here that's indicated by the trapezium. So let's try and find that out. Let's find out this by making a right angle triangle right there. Okay, as you can see. This 4 here is the same distance or height as this. So we can also call this 4. Right? Now if I do the same thing on the other side, these right angle triangles are identical, but just the reflection of each other. So this is 8. And this part's 6, right? Then the remaining part, which is these two distances, have to add up to become 2, which is 8 minus 6. But because these two add up to become 2, then each of these must be 1. So I'm just going to label that 1 right here, and 1 right there. So now we've got a triangle here, okay? So I'll just bring that out so you can see that. There's your right angle triangle right there, where this is 4 and this is 1. So let's try to find out what c is. Okay, we'll call this c. So c squared equals to 4 squared plus 1 squared, and that would turn up to become 17. And applying the square root to both sides without putting this in our calculator, the c squared would square root to become c, and 17 will become square root of 17. Then we can find out the total perimeter. So in total, there are 4 lengths. These two being the same, which are both root 17 plus 6 plus 8. So we can do 2 times of root 17, or root 17 plus root 17, plus 6 plus 8. So if I do that on the calculator, I will get an answer of 22.246, etc. So because the question says to round to two decimal places, we are going to get 22.25 millimeters. All right, E. Now for question E, okay, how do we actually do this? Well, we've got a shape which is originally a sector, okay, or a quadrant in this case. This shaded area here, okay, is enclosed by this arc here, okay, and this line here. We can actually find this line by using this right angle triangle. The distance on the very bottom is 5 meters because these two have double dashes. So we can find this by using Pythagoras theorem, but how do we find this part? Well, this part is just a portion of what was originally a circle. So we're going to have a quarter of its circumference, which we know as 2 pi r. So let's just do that later. Let's just try to find out what c is, and then we'll add it with, we'll call this x. Okay, so let's find out what c is, which is the hypotenuse. So c squared will equal to the sum of the shorter side squared. So 5 squared plus 5 squared, that is 50. And when we take the square root of both sides, we leave it at square root 50 in exact form. We don't round it, we don't put in our calculators, because this is not really what we want in the end anyway. We want the perimeter. Then let's try to find out what x is. Now remember, c equals 2 pi r. That is the total circumference or total perimeter around a circle. So we're going to have a quarter of that because this is just a quadrant. Or we can write 90 out of 360 if you want to. So I'll just stick with a quarter times 2 pi r. That's a quarter of the circumference that we usually have. And the radius in this case is 5, as you can see here. Okay, so that bit there is our radius of the original circle. So again, if I was to add this, okay, I would times the numbers on my calculator, but leave out the pi for now. So I get a quarter times 2 times 5. That's 5 on 2. Okay. So if I multiply that by pi, I'll have 5 pi over 2. Okay, for now. Right. So that's what we call exact form. Then what we do is we add these two things together, our value of x and the value of c. So our perimeter is then going to be the square root of 50 plus 5 on 2 of pi. So let's put down our calculators. Root 50 plus 5 on 2 times pi. That will give us a perimeter of 14.925, okay, which to two decimal places, I'll just write up here, is 14.93 meters. Okay. Now we do something similar for question F. Question F contains the arc length of 3/4 of a circle, or 3 quadrants worth, and then a hypotenuse of a right angle triangle on the bottom left. So let's try to find out C, and we'll call this X. Okay, so C squared is 2 squared plus 2 squared. And you might notice that from also the last question, these two are the same as well, and these two are the same as well. That's because they are both radii of the circle. So if I get 2 squared plus 2 squared, I will get the number 8. And taking the square root of both sides, I will get C equals square root of 8. Then let's find out what this arc length is. This arc length is 3/4 of the total circumference, right? So that's because there are 3 quadrants worth of 9 degrees there. Okay, so alternatively, you can write 270 over 360, but you don't have to. We can write x equals to 3/4 of 2 pi r, which r is 2 in this case. So if I then multiply 3/4 with 2 on my calculator, I will get the number 3. So I'll get 3 pi in total. That's exact value, okay, without typing the pi. Then our perimeter is simply these two added together. So that's going to be our square root of 8, okay, plus 3 pi. And so P would equal to root 8 plus 3 times pi. That will get us 12.253, dot dot dot, because there's more numbers, and that rounds to around 12.25 meters.